Okay everybody, this is a video to learn how to calculate the number of protons, neutrons, and electrons using the nuclear symbol. So first thing to remember is protons, I use this P with a superscript for the positive. Neutrons, I'll use an N with a 0 because it's neutral. And electrons are negative. And what you're going to need to remember as we go through is that these two particles are our heaviest particles that are subatomic particles in an atom, and they are found in the nucleus. Electrons are on the outside as a cloud. So go back and look at those notes and watch the video on the notes before you move on. The protons alone are the atomic number. The neutrons are going to be in the atomic mass along with the protons. So the neutrons plus the protons, the neutrons plus the protons equal the nucleus mass. So we will be able to go through something like oxygen, and we will be able to say number 8 represents the number of protons. O is for oxygen, and 15.99 is the atomic mass. The atomic mass we are always going to round to its highest whole number. So the 9s round up to 16. The reason for that is that's an average atomic mass, and the number of neutrons varies in mass. Therefore, we have an average on the periodic table. If we round this number, that's the most common mass, or the most common number of neutrons. But this is going to be the number of protons plus neutrons. So before we get started here, if I asked you, what is the number of electrons? Well, the very first thing you need to notice is that there is no oxidation number or charge. So therefore, this is a neutral element. If it's neutral, then the number of electrons equals the number of protons. So all you have to do to figure out the number of electrons is to identify that it's neutral, and the atomic number is the number of protons, and protons equal electrons, so this electron number is 8. Protons and electrons are equal when neutral. If I ask you for the number of protons, that's the easiest one. You just look at the atomic number, the smallest of the two, and that is going to be 8 as well. So we're neutral, because think of this as negatives and positives. They totally neutralize each other out. So the question then is the neutrons. So the neutrons is always going to be taking the atomic mass minus the atomic number. So in this case, it ends up being 8 as well. So 8 neutrons, they're equal to the protons. That's a coinky-dink. It's just nice. Sometimes that happens. So the reason we can do that is if this is protons alone and this is protons and neutrons, take out the protons, you're left with neutrons. Okay, so we're going to be calculating numbers here from things that they give us. So boron, first thing, the symbol is B. So we know we are right here on the periodic table. So if you want to have your periodic table out. They told us the mass number is 11, which makes sense because they rounded that up. If they said it was 10, use 10. That means they give you an isotope of it. They just have less neutrons in it. So go with the mass they give you as a whole number. Or if they ask you for the mass, round it up to the whole number. That's the only trick here. They give you a mass of 11, an atomic number of 5. Protons are going to be 5. Well, are they? Yes. And the number is 5. So these two columns right here, atomic number and protons will always be the same. And since these are all elements, so will electrons. These 3 columns will always be the same. So we could say right away, atomic number 11 has 11 protons and 11 electrons. If I have 39 electrons, then I'm going to have 39 protons, and I must have an atomic of 39. So let's go do this Y. So I'm going to go find atomic number of 39. Right here. Yttrium. Say that one, yttrium. That's a fun one. And let's see what they gave us. They gave us 89 as the mass. So, okay, so they just rounded that up to 89, and that's good. So they give us 89. So that's yttrium, 39 protons, 39 electrons. How many neutrons does it have? Well, you're going to have to take 89 minus 39, equals 0, 50. 50 neutrons. So the mass number minus the atomic number gives you the number of neutrons. So this is going to be the mass minus the atomic number gives you your neutrons. So you're going to go through and you're going to start calculating. So let's do one more. Let's take a moment here. Let's see if you guys can go through and do copper. Let's take a minute, see if you can mentally go through and get the parts of copper. Have a periodic table out. Start with the easy stuff. Atomic number is protons. And it is electrons. And then don't start looking for copper, look for 29 right here. Cu, capital C, lowercase u. There's a lot of good jokes there. See you later. Work from there. And then the mass number you can work backwards to. So the mass number is always going to be protons plus neutrons. So instead of taking the mass number minus the atomic number to get the number of neutrons, now we're going to work backwards and we're going to say the neutrons plus the protons. So don't look it up and round. Look at what you actually have and put these two together. So take these two numbers and add them together. Some of you can do it in your head. Some of you are going to want to go ahead and just take your calculator, 35 plus 29. So 64. And let's see what the periodic table tells us. Yep, if I were to round that, I'd have 64. If you would have come up with 63, that's okay. Write down what you have. That's known as an isotope, something that has one less neutron. Neutrons don't define the element, protons do, so it's okay that that's not the case. I'm going to stop there. You have a sheet like this one to do in your notebook, so go ahead and do that.